Hello guys, welcome back to our Form 4 chemistry, Form 4 chapter 3 chemistry, empirical formula. So for empirical formula questions, right? Come on, let's read this one. Aspirin, okay, they say, my pen. Aspirin is used to reduce fever and relieve mild and moderate pain. Okay, next. And then it says structural formula of aspirin is given. Okay, aspirin is used to reduce fever and relieve mild pain. I mean this is getting near the more modern and traditional medicine at the end of the Form 5 chapter. But for your information, aspirin is a painkiller. Aspirin is considered as a modern medicine and is classified as your analgesic type, more energetic medicine. It's a painkiller. For example, you have your what? You have your codeine, you have your paracetamol. These are considered as your analgesic medicine. So aspirin is used to reduce fever and relieve mild pain. Of course, is to when you are having fever, high fever, you can use aspirin. But usually we take paracetamol. Then this is the structural formula. Next, structural formula, right? Please don't confuse. Just steady, okay? The moment when you notice this thing, don't be stressed, don't be panic, just relax. Next, state the meaning of the molecular formula. Again, molecular formula, we already know. The answer says what? The answer says, oh, molecular formula means, of course, it's a chemical formula first. Oh, chemical formula, it's a chemical formula that shows what? That shows the actual ratio number of atoms of each element in a compound. Don't forget your atom. So let's write it down first. It's a chemical formula that shows the actual number ratio of atoms of each element in a compound. Done, nicely done. And there you go, you get your 1 mark. Okay. Next, we go to the next question. Okay. Next question says what? Write the molecular formula of aspirin. Okay, molecular formula, this thing, right? It's not empirical formula whereby you don't have to simplify it. What you have to do is you just have to calculate. You just have to calculate according to the structural formula given. What do I mean by that? Basically means how many C here, how many H here, how many hydrogen, how many carbon, how many oxygen here. You just write it down. Since it's a molecular formula, you don't have to simplify it or make it into a whole number. So let's count it together. How many C do we have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have total of 9 carbon. So we write down first 9 carbon. Next, let's look at our H. So how many hydrogen do we have? 1, 2, 3. Sorry, let me change my color first. I'll use blue or yellow. 1, 2, 3, 4, 5, 6, 7. There's total of 7 hydrogen. Nice, 7 hydrogen. And how many oxygen? I'll use blue. Oxygen, we have 1, 2, 3, 4, 4. That's all. We have 4 oxygen right now. So this is our molecular formula. So let's write down without further ado. Molecular formula will be our C9H7 and O4. Nicely done. That's your 1 mark. Wait, did I calculate wrongly? Wait, let me try. How many H is there? Are there? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Oh, I'm mistaken. Okay. Sorry, here there's one more H. There's one more H here. I think I accidentally rub it just now, the moment when I draw the line. So there's total of how many? This is, this structural formula, you don't have to remember it. In exam, they'll give it to you. So they might not give aspirin, they might give you other chemicals. But in this case, we actually have 8 we have 8 hydrogen. Okay, 8 hydrogen. I accidentally rub it. We have 8 hydrogen. 8 hydrogen and 4 oxygen. Okay. Next question, state the type of particle in aspirin. So type of particle, I mean, nothing much to explain about. This is molecule. Okay, molecule. So write it down to get your 1 mark. Next, okay. This question, right, is actually similar with, oh wait, I cannot zoom in. Never mind. This question is actually similar with the previous one we do. So let's try to read the question first. What it says. Carbon compound P, okay, contains of 6.67% of hydrogen, 40% of carbon, 53.33% of our oxygen. So remember our previous question, what do? Is we take the percentage as our mass and calculate it right away, right? Okay, you do the same thing here. But what's different here is they do not prepare the table for you where you need to write it by yourself. So first question says what? What is the meaning of empirical formula? Again, hantam what you remember. You just have to remember nothing much. Empirical formula first is a chemical formula that, hang on, is a chemical formula that shows the simplest, remember, simplest whole number ratio. It's a whole number, yeah. Simplest whole number ratio of atoms of each element in a compound. Done. That's your 1 marks. Next, here, finally, the table thing where you actually get 3 marks, which is very, very important, this part. So first of all, of course, you're gonna label everything first. So you have your element. I will use blue pen, element. Then what's your element? You have your element as your carbon, hydrogen, and oxygen. Next, very next, we have after element is what? Let me think. After element is, oh, I remember. After element is our number of moles, right? Number of moles. Oh, sorry, not number of moles, our percentage. You can either write percentage or you can write your mass is the same. So for this case, our previous question, we write percentage, right? So right now we write mass. After our mass, we will have number of mole. Then after our number of mole, we have our ratio, simplest ratio. Mass, how much is it? Mass, okay. Mass, we have carbon, how much? Carbon as 40%. And hydrogen as how much? Hydrogen at 6.67. 6.67. Then our oxygen, how much? 53.33. 53.33. Very nice. Then after our element, we have our mass. After our mass, or you can say percentage. And then what do we have? We have our number of moles finally. Number of moles. Number of moles. Okay. So how do you calculate number of moles? Simple as that. Mass divided by molar mass. Okay. Our mass is 40 divided by carbon relative atomic mass is our 12. So how much do we get? We will be getting 3.33. Next, hydrogen, the mass given 6.67. Then the relative atomic mass for hydrogen is 1. So whatever divided by 1, you get back the same number. Let me rub this off. Next, we have our oxygen. Oxygen is 53.33 divided by our oxygen is 16, reactive atomic mass is 16. So answer that we get is 3.33. So after we find our respective number of mole, what we're going to do is we are going to do our final thing. What's the final thing? Our simplest mole ratio. This is very important for you to find out your empirical formula. So let's write down first, simplest, simplest mole ratio. Simplest mole ratio. So simplest mole ratio, either you simplified it or you times it. So in this case, we are going to, sorry. Simplest mole ratio means you take the smallest number from above and divide it. So in this case, the smallest number obviously is 3.33. So 3.33 divided by 3.33 for our carbon will be 1. 6.67 divided by 3.33 will get 2. Divided by 3. Divided by 3.33, we get 2. And for 3.3 divided by 3, again, we get a 1. So as you can see, this is already our simplest mole ratio, as it's already in whole number. It's already in whole number where we don't really have decimal inside. But there's some cases where you see like, teacher, why I noticed there is mole, and then there is like simplest mole ratio one. The reason being they separate, I use red pen. The reason being they separate mole ratio, and finally, simplest mole ratio, is because that when you're doing a mole ratio, you haven't get your whole number. The moment after you finish your, the moment after you done your mole ratio, you realize that after all the division, I realize that I still get decimal point. That's the moment when you need to refer that as your mole ratio, and then you do again your simplest mole ratio to get your whole number. Because sometimes after we do our division, we get decimal point. That's not what we want, because empirical formula says what? Empirical formula says that, oh, they want simplest whole number ratio. So that's not what we want. That's why at some point we put mole ratio, then baru we put simplest mole ratio. But in this case, we can just directly put our simplest mole ratio. Why? Because after we do our division, I realize that I get whole number. So after all this, we can finally draw our line. In exam, please draw our line, okay? Okay, nicely done. And lastly, the final thing that always people forget to do is that they forget to mention the empirical formula. So please write it down. Empirical, after your table, empirical formula. Empirical formula. For you, my pen is running out of battery. Empirical formula is what? Is C1, refer back to your table. Carbon is 1, so C1. You don't have to write the 1. CH. H is how many? H is 2, so write down 2. H is 2. And your oxygen is 1. Done. Okay? Your oxygen is 1, where you don't have to write. So your empirical formula here is CH2O. Okay. So you get your 3 marks here. Very, very nice. Like, very nice. Okay, the next question gonna be more interesting, because what they're gonna ask you to do is they're gonna ask you to find the molecular formula of your compound P. Okay, so we read back the question. We refer back to the question. Okay, the compound P. Oh, so just now we are calculating compound P, calculating compound P. So it is given that a empirical formula for compound P is CH2O. Then what they are asking right now is they want a molecular formula. So molecular formula again is the original one, which means the how we call that the whole the actual ratio number of atoms of each element in a compound, right? So let's read the question again. The relative molecular mass of compound P is 180. First, the moment when I read this question, please label it first. The RMM for compound P is 180. That means the relative molecular mass basically saying your molecular mass is 180. 180, okay? Next, what I want you to do right now is calculate the molecular formula. They want the molecular formula of your compound P, where just now we find empirical formula. Now we want molecular formula. Basically, what we're going to do is terbalik. Terbalik, how do you terbalik? There's actually a formula. This formula is not really a formula, but it is a formula. So what you're going to do is, first, you hantam your empirical formula inside. So what's my empirical formula just now? Refer back is CH2O, right? So CH2O. Hang on, am I right again? You hantam your empirical formula inside. So what you get is CH2O, right? What I want you to what I want you to do right now, very simple. You put a bracket and then you put an N outside here. And then what I want you to do is put a equal and then you put 180, your relative molecular mass. And then for your information, right, relative molecular mass don't have unit one. So please don't go and ask your teacher or ask any teacher that, hey teacher, molecular mass in terms of gram or in terms of kg, no such thing. Relative, the word relative molecular mass, relative isotopic mass, relative whatever mass, okay, there's no unit, no unit. Okay, so here, after you hantam this thing, right, start to put your relative atomic mass inside. What do you mean, Nicholas? Okay, come. So the formula basically means like this. Where you put your empirical formula inside, and then you put bracket, and then you put an equal, and then put your relative molecular mass. And then what I'm gonna do is I hantam every relative atomic mass inside, which means my carbon is 12, my hydrogen is 1, right? Relative atomic mass for hydrogen is 1. Refer back here. Refer back here. Okay. My hydrogen is 1. So 1 times 2 occurs 2. And you get back to 2. 1 times 2, 2. And then my oxygen is what? My oxygen is 16. 16, right? So how much there? 16, just 16. So put add up with 16. And then put your N here. Just copy and paste everything. And then what you're gonna do is, of course, add them all up. So what you're gonna get is you get 30. And then copy and paste again. Right. So of course, this is more like our maths already right now. We have come to a point where we start to do mathematics. So of course, you bring it down right over there. You're gonna get 180 divided by 30. You're gonna end up with what? You're gonna end up with your N is equals to your 6. Okay, at this moment, you ask me like, hey teacher, what do you mean by N is equals to 6? I don't understand. N is equals to 6 means you substitute it. As simple as that. You substitute it, nothing much. Don't confuse. Which means the moment when I put N just now to find out my molecular formula, the N is for me to substitute back into my empirical formula to get back my molecular formula, which means my original formula. So start it back. You copy and paste everything first. So we copy again. This time I'll use blue pen. Hang on. What happened to my pen? Okay. What happened to my pen? My pen just ran out of battery. Never mind. Okay. So again, CH2 and then O. And then N just now we just put N, right? Now we put 6. Because we already found it, right? It's 6. And then again, 180, you don't have to write down already because the 180 is for you to determine the n. So after you find your n, this is all you need to write. And afterwards, what do you need to do? You substitute in. So times it in, multiply it. So you will end up with C6H12, 6 times 2, 12, and then O6. At this moment, did you realize something? Did you realize that, teacher, I realized something. I found back the original glucose formula where just now, right, the empirical formula tells me CH2O. Basically, if I give back you the glucose formula, remember our previous video, I give you the glucose formula C6H12O6, I ask you to simplify it, you get me something, you get me CH2O. Remember, when I asked you to determine the empirical formula, what you find out is CH2O. And then now what this question basically telling you is just reverse the process, and then you still get back CH12O6, which means they are both equally related, where you just need to remember the formula in order to switch them. So thank you guys for watching. So we will continue the next video next time. Thank you.